need to just revamp our education system. Because you know what? We don't learn anything. It's never it's not comprehension. It's just retention. It's just rote. That's it. We never get it. We just keep it long enough to spit it back out, pass the test, and we get rid of that. Right? It's like the teacher gives you something, you go, okay, I got that. The time for the test, okay, here you go, giving it back to you. Done with that. It's like our brain's a big etch-a-sketch. We go. Okay. Next subject.
You know why this is funny? It's because it's true. You've had to learn things, then forgot them faster than you learned them. And unfortunately, kids today still are. And I have to tell you that I appreciate it anytime someone points out that it's the what and the how we are teaching that is the problem in schools. All too often, school reform models point to funding schemes and other things that really aren't pointed at what I consider to be the heart and soul of the school, the teaching and the learning. And that's what we really need to focus on in school reform. And in that discussion, we need to consider new subjects and fields of study, such as technology and engineering, not just those things that have become ingrained in school tradition. Welcome to Education for Innovation. I'm Dave Janos. What you find as you look at how students study technology and engineering in schools is actually very well grounded in learning theory, both traditional and contemporary. Let's consider an age-old model used to describe the ways and means of student learning. It's called Bloom's taxonomy. And if you ask any educator what it is, they'll be able to tell you about it. It presents a hierarchy of types of educational objectives, and at the bottom you have the things that are relatively easy for the students to do, learn for knowledge and comprehension. Knowledge means simply knowing, for example, basic knowledge and facts. And comprehension may mean that a student is able to do something a bit more advanced to demonstrate their understanding, such as comparing and contrasting things. Then as you move up to what are known as the higher order thinking skills, you find things like application, analysis, synthesis, and evaluation. Well, the basic point here is that too often still, our schools are too heavily invested in the basic knowledge and comprehension. And what research tells us is that when students have the opportunities to do the things that would fall into the upper areas of this model, that they learn the material better. They recall things longer, and things tend to make more sense. Actually, part of the problem here is that those things at the higher levels of our Bloom's model are very difficult to assess. And because no one can seem to figure out how to broadly assess it, which, by the way, is usually done for the sake of comparing school districts to rank or fund them, we end up losing what every educator seems to know is valuable. Another very commonly accepted theory in education is that of Gardner's multiple intelligences. In short, this theory and associated research tells us that if we could teach to more of the different ways students learn, the better they will learn what you're teaching. This means that we want to teach to the visual, spatial, bodily kinesthetic, logical, mathematical, and the other ways that students acquire knowledge, because they all learn differently. So again, let's hear from some practitioners describe what they do with technology and engineering students. I think you'll find some much better approaches to teaching and learning, and ones that are grounded properly in learning theory.
School may have done more damage than good because they're always told what to think and what to remember. And we need to change that and teach them how to take a little risk, how we don't know what the answer is to everything all the time, and there's multiple answers, and some are better than others. And that really helps build the self-esteem when a team of young kids solve a problem and they see the solution and it's tested and it's proven that it works.
The classroom, practice that some of the teachers are doing are just that. They're just going through motions, plugging in numbers of formulas and pictures. And yet when they have to do it from scratch and lay out where side A, B, and C are, and angle A, B, and C on a triangle or something, they don't know where to begin. Because I took the time to show them where it really applied to something and they needed the information to finish the design of their product, it meant something, and they're more likely to remember it and be able to use it again.
I think these are things that are unique to us because of the nature of the type of class that we teach and the situations that we can put our students into, where it's applied learning versus theoretical learning.
A good educational theory tells us that if you want kids to learn, teach them theory and then have them apply it. I'm saying that's that's good, but it's not good enough. It's wrong-headed. It's not even wrong-headed, it's headed wrong. It ought to be turned backwards. We teach application first. And people ask, well, how do you teach application if the kids don't know it? If we can give them design problems that fall within their experience, they can apply what they know to that problem, and then we can use that or a combination of several design challenges strung together as a foundation for them to grasp the theory.
These other classrooms are stopping at knowledge, recall, comprehension, and a little bit of application. There's no synthesis and evaluation of what they're really going to need this stuff for. And that's what I find we're able to provide to the students, that we can actually get them coming into design problems from different angles where they wouldn't have normally approached it, or it wouldn't be presented to them in such a nice, neat package, and they've got to work through it.
I think that the content that I'm giving them in the context that it's given is much more valuable than specifically requiring them to know every little thing about some particular topic. Until you actually do it, I don't believe you understand it. You generate meaning by doing things, and when you do something, at the end of it, you can reflect back on it and say, I understand why that worked or why that didn't work, and you truly become an educated person.
I know that if we went back and talked to John Dewey, he would have said that project-based learning was important because it brings all the subjects together, and that when one subject is learned side by side along with another one, because they're dependent on each other and they're within a singular context, that project-based learning, the things that you learn through that project stick with you longer. You can recall them better. You have multiple contexts for recollection, as opposed to learning the subject separately.
When a student can take concepts that are used every day in science and math and apply them to something that's a hands-on design and build, there's many benefits to a student being able to experience this. So the four disciplines work together as science and math build up content knowledge. An application scenario in a technology or engineering style classroom can reinforce and work together and tie them together on a global level.
So if you think back to our previous episodes about what students are doing when they study technology and engineering, you find that all these things are very well grounded in learning theory. Students design products and systems to solve problems, and that requires them to analyze a problem or situation and apply knowledge to solve the problem. Designing something is, in and of itself, synthesis. And evaluation is actually one of the steps in the problem-solving process that we teach students. Also, designing a product or system requires students to think in terms of physical space, and when they actually make a project, it becomes more meaningful in a bodily kinesthetic way. These are the types of things we need to prioritize if we want students to learn, and if we want to teach them true innovation skills. We need to change what we teach and how we teach it, and consider new subjects in the school curriculum rather than the ones we've simply accepted because of tradition. It's the only way to take the Etch-a-Sketch learning out of the mix. Thanks for watching and listening. We'll see you next time.